Hello, everyone. I understand that I am what's keeping you away from beer. So let's have some fun. I'm sorry, I meant Maroon 5. So let's have some fun. Let's go through some of the fun stories, some of the theory about wireless troubleshooting on the Meraki dashboard. Before we get started, please use Cisco WebEx app on Cisco events. I was informed that the file for the session is missing, so I made the teams aware of this. If it's still missing after the presentation is done, I'll make sure to upload it within half an hour. My name is Jakub. I come from Poland. On a daily basis, I live in the UK, in London. Proud father of 2 kids and a Dalmatian. I'm better in wireless than I am in fishing, but I'm very proud of those fishes on those pictures. And I'm also part of the Cisco Wireless, Cisco Live team for the wireless. So I'm responsible for the wireless for Cisco Live in Europe, Cisco Live Vegas. And on my day job, I work in the escalations team, right? So I'm in a break-fix kind of role. And yeah, dealing with pain is my hobby. So let's get to it. We'll cover some of the troubleshooting principles that everyone in my team follows to solve problems. We believe that we're trying to help you. If we're part of the problem, we're not really part of the solution. So we always try to take a 360 view at all the problems to help you as much as we can. And then we're going to go through a normal journey of troubleshooting the most common wireless issues. We'll look into AP cloud connectivity, because clients cannot have issues if the AP is offline. And then client join issues, performance roaming, and all sorts of fun. So every time when a case gets escalated or gets raised, we get a lousy statement like this: Wi-Fi doesn't work, and try to figure out what's going to happen. Even during a keynote demo, when they asked the AI assistant, hey, why is G2's phone offline? They blamed the Wi-Fi, right? They said severe network outage, wireless is down. And the #1 mistake that people tend to make is after wireless doesn't work, they try to make a lot of random changes, try to fix, click some buttons, and then it makes things even worse, okay? Because without knowing what the actual problem is, how can we fix it? When users come to us, they are very rarely right about what is the cause of the problem. But remember, they're always right about their user experience, right? It doesn't matter that we think that everything has been configured correctly. If they think it doesn't work, then it doesn't work, and we have to understand what doesn't work and help them out, okay? So some of the user-reported problems might include wireless is unusable in a meeting room, everything is slow, we have random disconnects. But what it actually translates to us as engineers are proper technical issues. Sticky client issues, do we have issues with oversubscription, high cell overlap, do we have hidden node problems, or is something happening on the wired side of the network? So asking the right questions will help us to get closer to the actual problem statement. These are the main questions that my team always asks when we get a Wi-Fi doesn't work kind of scenario. For me, the most important things are, I want to understand what device is having issues. What is the SSID? Is it using some specific features like radius? Is it using some cool features like 11R, 11K, 11V? But most importantly, what is the business impact? Okay? Because sometimes something as simple as printer not connecting to Wi-Fi may become a P1 if that printer is in the CEO's office. And then after we scoped it out, we get a problem, it must be a problem with Cisco, and then everything blows up internally and we get to it. I'd like to think that you don't believe that this is a problem with Cisco, it's just you do like working with us and our teams, and we always pick up the phone when you guys are in need. So hopefully by asking the right questions, we can go from Wi-Fi doesn't work to something where we know exactly what device doesn't work, what firmware is it running, and what is actually happening when the issue becomes evident. But how often do we get a statement like this? So after we have a proper problem statement, it's important for us to identify where do we suspect the issue to be, okay? So in the world of wireless, we define 3 main relationships, and that also translates to 3 main points of troubleshooting. We have AP to client, so that would be anything on the downlink. If the downlink is slow, this is where we want to focus. Client to AP will define the performance and quality of the uplink. Then we also have relationship that's being formed between APs, right? Whether this is on the wireless side, so this is important because that telemetry, that data is then used by RRM, AIRRM to come up with all the transmit power plans and channel plans. But also on the wired side, it's important to understand how those APs communicate because, for example, during a roam between two access points, they need to exchange the information about the keys, about the client state. So we have to understand how everything is interconnected before we start to act. Then, when we zoom out, we see a lot of other things, right? We can go through multiple switches, multiple data center. Do we go through the cloud? Do we go over VPN? So we need to focus exactly where the problem is, and we'll solve it. So once we have all this information, it's important that we don't jump to troubleshooting just yet, because we have to validate the layer 8. Because sometimes the user get very creative with their expectations, and they're very far from reality. A very common example, and a lot of people actually do it, my wife does it. After COVID, when everyone was asked to go back to the office, people used bad Wi-Fi in the office as an excuse to work from home. And it was common to receive something like this: speed only goes beyond 100 meg. And you're like, what do you mean? It's really good. And turns out the expectation was that because at home they get over 500, they expected to get the same in an enterprise environment. And we know that home Wi-Fi and enterprise are not made the same. They're significantly different. So yeah, once we have the problem, all we need to get is pickups and logs, and we can fix anything, right? I think pickups are better than logs, but again, opinions are split. So how does AP connect to the cloud? There are multiple steps. Here's a cheat sheet for you guys to take home. These are all the steps and all the tests that need to happen and be successful in order for AP to come online in the cloud, okay? Every single dashboard organization that is created, that you have access to and that you manage, if you head over to help, get help, there is a firewall info page that lists all the IP addresses, all the port numbers that you need to have enabled on a head end to make sure that the AP can communicate with the cloud. If the AP has issues, then we have to do basic checks, right? If you have a Meraki switch connected, if you have the AP connected behind Meraki switch, then it's actually quite nice for you because it's so simple to take pickups, and you'll be able to validate everything. However, that pickup will not include Meraki Cloud reachability, okay? Because how everything is configured when pickup is taken, the Meraki Cloud connectivity port numbers are excluded. This is because if you troubleshoot a legitimate problem on your network, there's so much of the cloud traffic, we don't want to make the pickup too noisy. Then, if you don't have access to taking pickups, what you will need to do is access the local status page. On the local status page, you'll get some guidance as to what might be happening. Access points in the cloud mode will also broadcast a specific SSID saying bad gateway, bad DNS, whatever. But once you access the local status page, you can download the support data bundle that you can then upload back to support. We can decrypt it, take a look what's going on, and tell you exactly what is failing. I always try to be effective as I can be with my time. I don't troubleshoot a lot of AP join issues. Most of the time when the case gets escalated to my team, it's more serious than AP not checking in. But I'm trying to get creative. I'm trying to maximize my time. So for example, if I see a network like this, I can already pick up that I'm looking at APs from 2 different subnets, and it's specific subnet that has issues with cloud reachability, okay? So maybe there's something on a head end that has changed. Most of the time, it's actually a little rat, a mouse, or a forklift that decided to destroy the cable. So don't forget about validating the layer 1, okay? Specifically when it's only 1 out of 10 or 1,000 of APs. Now let's look at the client itself. So to fix a client, we have to think like one. So what is client actually responsible for? It's responsible for 5 things. It has to select an AP. It has to associate and authenticate. Then it's responsible to select the data rates used for the uplink transmissions, roaming, and my personal favorite, random disconnects. Everything's good. They always have to randomly disconnect out of nowhere. So client join itself is quite straightforward if we break it down into the 3 stages. AP selection is quite basic, but sometimes it's complex. Depends on the algorithm of the chipset itself. Most of the time, the client looks for the AP with the strongest RSSI, but now that we have new generation of wireless, we can use wider channels. They look at things like, okay, I prefer 6 gigahertz, I prefer 40 megahertz, I prefer specific security ciphers before I connect to it. Once it's selected an AP, it has to associate and authenticate, okay? They need to exchange the compatibilities, do all the handshakes, and last thing, it needs to do all the things on the wired side, get an IP, ARP for the gateway, do a DNS, and off it goes. So a customer comes to us and says, we have a P1, no one can connect. And now for me, I don't know your network. I look at a lot of networks on a weekly basis. So I always follow a specific flow, right? First of all, I want to understand the general state of the network. And once I know how the network looks like, then I'm taking it step by step to get a bit lower and lower. So the first page I always use is the assurance, okay? That will give me an overview of the health state of the network. So here we see that some clients are having challenges with association, some with authentication, but the health score is 100 out of 100. It's definitely not a P1. Next thing I do is I go to the health page, because the health page will tell me a bit more and it will guide me in the right direction. So here we see that there's only 12 clients failing out of 600, so definitely not a P1. And then what this page allows me to do is once I click on any of those icons, I can expand and dwell a bit deeper, okay, and understand exactly what is happening. Why is the assurance reporting some issues, okay? So we go back to our lovely customer and we say, well, it seems only a handful of devices have issues over the past 2 hours. Can I have more details, please? And this customer really believes there's a P1, so he says, oh yeah, all the .1x protected SSIDs have an outage. Okay. Well, let's go back to the health page. And here we see that only a subset of all the connections failed, right? What I like to do here, because most of the SSIDs have multiple radius servers, perhaps there's a specific IP of the radius that's failing, then this graph will become all red, okay? So then I will pick a random client that will take me to the timeline, and here we can see that the failures are happening because of the radius timeout. So essentially, the radius stopped responding to us. On those pages, you can also find a lot of interesting information. So for example, here, looking at the assurance overview and the health state of all the authentication requests, we can see 2 clients sending a lot of authentication requests. And if you think about it, a client that is not connected to your network is not a happy client, okay? Every time they do authentication request, they are spamming your radius server, right? So there's more utilization of resources. They also have to get on the medium, on the wireless a bit more often, so they're taking the precious airtime away from the clients that actually need it. Here is an example of a client that is potentially trying to do a brute force attack, right? Again, never assume that people try to hack into your network. First of all, assume it's a misconfigured, misbehaving device before assuming, someone wants to steal your data. But we went through multiple pages. That means multiple clicks. That's not very effective. It's 2026. We have AI. Do we really need to do it? Well, yes, we still need to click, yes. But we have a new workflow that the team has been working on for the last couple of months. This will get released in 2 weeks to a month. It's called Experience Metrics. So over here, we can see that the entire experience of wireless connection and the wireless state of your network has been split into 4 categories, and they focus on simple questions. The first category is, can devices connect? Okay? Are devices failing? How long does it take for them to connect? Okay? So after they have successfully connected, can they connect within 1 second, or does it take more than 5? Is the wireless itself, so the radio frequency, good enough? Okay, do we have issues with the RF interference and stuff like that? And it also looks at the state of your design. Do you have enough coverage? Do you have potential gaps? So let's look at a particular example. We actually were looking at this at customer's network last night, and so that's a real life. The good thing about this page is that we immediately draw your attention to where the problem might be, okay? So here we see, okay, authentication is the main contributor to all the failures. And we see that access point 08 is the main offender, okay? So let's go the next step. So here what we see is that on a specific SSID that was reported, there are 2 radius servers, and the failures are evenly balanced between the 2 IPs, okay? So because it's not 100% failure on one IP, it means it's not a server down situation, okay? So then we go the next stage, to the next step, and we see that a single AP is contributing with a 100% failure rate. What was the issue? The issue was that AP was never added into ICE. So all net new associations failed. So what was happening is clients would go into that area, attempt to connect, they would fail, they would then connect to another nearby AP, and then because RSSI of this one was so strong on the roam event back to that AP, because that customer was using fast transitioning, then it was working. So it was a very silent failure. It's very difficult to find. But yeah, I was very impressed that Experience Metrics is capable of helping us to identify those issues. And then we said all of that and CEO cannot connect. Ooh, now we have a P1. So we went through looking at the overall state of the network. Then we looked at some of the examples. But now we have an actual user. We have a specific device that cannot connect. So with this information, what can we do? We can go to multiple pages on the dashboard, depending on what we want to look at. We can go into the client details page to look at the timeline. We can go to the wireless health connection log, look at the actual event log, or my personal favorite, look at the pickups, right? So event log will split every single event along the way one by one, okay? Sometimes it can get very chatty and verbose. We may not have time or don't want to look at this. If I know there is a specific failure, I go to connection log, because connection log shows me only the failures, and in a single liner it gives me all the details, reason code, and I can make some hypothesis based out of this. And timeline is what sticks together the event log and the connection log, right? Then, if we have the pickups, it's amazing, but what do we know about pickups? They're very expensive, right? Because you have to be there, you have to know exactly when the client's having issues, you have to go to that client, you have to replicate it, take pickups, it's a lot of work. But as of last year, we have a thing called proactive packet captures on the dashboard. I hope some of you already played with this, but what they do is there's a ring buffer constantly going on the AP itself, and if a client failed to join for a specific reason, that pickup will be extracted from the AP, uploaded to the cloud, and whenever there's a failure, that pickup will be waiting for you on the dashboard. On top of that, we have been teaching our in-house made AI model to analyze all those pickups for you, and you will see an example of that in the next slide. So after we looked at all the client join problems, security, authentication, there's still some other reasons why client may fail to connect, okay? Remember, wireless issue is not always wireless. If your client has an IP, it's not a network problem. But what can happen? So we can have issues with DHCP. Pool exhaustion, we can have issues with mandatory DHCP dropping the traffic. We had one example where a very, very extreme storm control was causing the ARP request to be dropped, and client would just be, okay, bye, I'm blacklisting that SSID, I'm not joining back. So here's an example of proactive pickups capturing a DHCP failure that resulted with client not being able to join. Not only that you get the pickup already in front of you, it's already analyzed for you, okay? It gives you very nice reasoning. And then you can select, for example, I would like to see the exact packet flow and exactly where it stopped, and you will see it right there, okay? I think it's pretty cool. I think for anyone getting started in the world of wireless, it's pretty cool because it draws all the flows and you can visualize exactly what is happening. So now that the client finally connected to our network, it's time for the client to have issues with the experience, right? I think there's 3 main reasons for bad user experience. The first one comes down to RF and design. Don't do in software what should be done with proper RF engineering. If you took shortcuts whilst designing networks, they will always catch up with you. So I know it's expensive, I know it takes time, but always put some extra effort into designing the network. So why can we have those issues because of design? We can have too few APs, right? Then we have limited RF coverage. We can have too many APs, then we have extended RF coverage. That will then cause issues with co-channel interference when management of channels is difficult, and you will have an issue with channel reuse and APs conflicting with one another on their RF. You can have issues with oversubscriptions. This is an event where you have a lot of clients per radio that are just spamming the data. That will result with data rate downshifting, a lot of retries, not a good time. The second category are channel changes. Okay? There are a lot of events that can trigger a channel change. It can be due to a DFS. It can be due to a normal RRM operations to optimize your network. And last but not least is roaming. Slow roaming, frequent roams, suboptimal roams, and no roams. But there's also a 4th reason for bad performance. Creative config, okay? I saw a lot of examples of very creative configs out there, and they bring a massive smile on my face. We always, every now and then, have someone who says, we need all 15 SSIDs enabled on that access points. We need to use all the bands. We need to use 2.4 because we have some legacy clients. We need to use legacy data rates. And I'm standing there like, no, you don't. No, you don't. And you're sacrificing performance of the Wi-Fi 7 laptops that you have over legacy devices, right? Also, you shouldn't use 80 megahertz channel on 5 gigahertz, especially when you use dual 5 gigahertz, because then you will run out of airtime and you will not even be able to send ICMP. But over the next sections, we'll dwell into that a bit more, so hopefully you'll understand why. So whenever I look at the dashboard, I don't know much, right? So there are specific things I focus on to understand the state of the RF of that network. So first of all, I want to look at the transmit power, the range, what is defined, what is actually being used. How APs hear each other. If all of the APs are using the lowest value from the range, then it means, okay, it's a very dense deployment. APs can hear one another very well. We can do some crazy stuff. One of the pro tips that I always use, when I define the transmit power range in a well-defined network, I want to keep that range as tight as possible, okay? I want to give the flexibility to RRM to go up by 3 decibels and go down by 3 decibels, and that's it. When you leave it by default between 2 and 30, then it's do whatever you want kind of thing. Channels and bands that are being used, okay? So in a well-working network, what I would expect to see is every single channel being used the same amount of times, okay? I shouldn't see, 50% of the APs using Uni1, and then the rest are using all the other bands, okay? I want everything to be equally balanced. If they're not, if they're specifically, let's say, using only channel 100, what is happening? Yeah, what is happening in that network? Is there perhaps an interference? Is there a rogue network that's interfering with other channels, which might explain why? Those APs are using only specific frequencies. In enterprise, we should focus on using 20 megahertz most of the time. 6 gigahertz, we have some flexibility. We're going to talk about it in the next section. Then I look at the data rates. How many SSIDs do you have? And I'm always trying to convince you that you don't need all of them. You can probably reduce a few. But that's a very interesting discussion because some people have their SSIDs named after themselves. It's a bit of their legacy, and they don't want to disable them at all costs. Also, for the data rates, my personal go-to these days is 24 megabits. It's really good. Think about it this way. The higher the data rate that you use for the management, you enforce clients to have a higher signal quality in order to get back and decode the traffic, okay? So although this energy doesn't disappear, you have to have a better quality link. You have to be closer to an AP in order to put some traffic. And disable meshing. In cloud mode, meshing is enabled by default. It's a hidden SSID. You know, if we can make it a better place and give more airtime, let's disable it if you're not using it. Then I look at options like RxSOP. Can we optimize the network by using some of the advanced options? Again, don't do in software what should be done with proper RF engineering, but okay, there's always something to be done. It's easier to click buttons than add hardware, I understand it, but we'll have an honest conversation about it. And then I'm trying to understand the RF environment itself, right? So how many APs do you have? How well do they hear each other? Is there a lot of neighboring networks that you do not control? And so this is the basic thing that I need to understand before I can actually help you or solve some of the problems. So looking at this sample RF profile, what do we see? We see that almost zero channel reuse, okay? So every AP is using its own individual channel. All APs are on lowest transmit power, so they hear each other very well. Possibly deployed in corridor with a clean line of sight. But now the question is, because the transmit power is so low, it's at 3 decibels, then it means a slight movement like this can result with an aggressive downshift of RSSI that will cause a really weird performance on mobile devices. Then you put that mobile device next to your head is minus 20 attenuation. It's gonna be a fun moment because the call will drop. That's why keeping a default RF profile will get you best effort experience, okay? So what we see here is that the design is all over the place. We have APs using 80 megahertz channels. We have APs using 20 megahertz channels and 40 megahertz channels. I can guarantee you that because clients do prefer wider channels, those APs highlighted in red will be oversubscribed because clients will never look back at those APs that only use 20. Okay? If you use default profile with all the default settings, you cannot expect anything. I always like to make my network as predictable as possible so I know exactly how it behaves in specific scenarios. So a quick example, we have 3 APs. We have a single AP with 3 radios. We can see transmit power on 6 gig is high. We can see channel width on 6 gigahertz is wide. So if I was a client, this is the one I would connect to, okay? And that actually hit us badly a few years ago when we were doing a deployment of very first deployment of 6 gig in a large public venue. We were still connected to an AP at great distance, like 150 meters, 200 meters. The RSSI on the client was minus 90. I was still able to push traffic. The client wouldn't even look back at 5 because that 6 gigahertz was made so appealing. Now my favorite question, but wouldn't AI RRM take care of my network? Yes, kind of, but it depends on the quality of your input, right? If your RF profile is garbage, then the results will be garbage. Remember, it's an algorithm, so whatever you feed it will be the same quality back to you. So yes, ARRM take care of your network, but make sure you design that RF profile to work within specific boundaries. Because let's think about it. The RF profile defines the success of our network, okay? Here are all the things that we have to focus on when designing an RF profile. Do we enable all the frequencies? Do we want to load balance clients from 2.4 to 5? The transmit powers, you have to be careful. If you set it too high, you might have sticky clients. You have no roaming and you have oversubscription. If you put it too low, then not so sticky anymore, but there will be too many rooms, right? So you have to keep a good balance. Same for channels and channel width. Not all channels are made the same. Different channels go with different rules. And think about it from the perspective of, if you enable all the channels, then client has more channels they need to scan. right? So roaming experience will be different because they will have more frequencies that they need to scan. Management data rate, use the higher. Again, I always go with 24 because that's the highest basic rate defined by the standard. When you go to 36 and beyond, yes, they do work in very high density environments, but it can get weird. And enable some of the cool features, okay? Do we want to enable 11K? In a cloud mode, 11K is enabled by default. 11V is disabled by default. The button client load balancing is what enables that. But do make sure that your environment is fit for purpose, that your clients actually make intelligent decisions with that 11V. I've seen some examples where things didn't go that well. So, misaligning transmit power on the same AP will cause an imbalance of clients between the radios, okay? So here is an example of an AP in dual 5 GHz mode. The way that load balancing is actually done is with physics. Slot 1, so the primary 5 gig radio, and the flexible 5 gig radio on slot 2, they have specific polarization pattern so that the load balancing is taken care of by itself. So here a customer tried to push more power onto the specific slot, and this was the result, okay? The one that was much hotter, had more clients. And in the same physical environment, those clients are sitting. The ones connected on 36 will have much better experience compared to the ones on 104, okay? Because you have more devices competing for the medium. So let's look at some common problems. All users report slow connections. Okay, so let's run some tests. So I was actually on site for this particular issue. And customer was reporting, oh, the speed test is so slow. But then when I ran the ping test, I was already getting dropped on the ping. So why would we focus on troubleshooting speed tests, which is, layer 3 and above, where ping, layer 3 and below, is already failing, okay? But let's analyze that data, okay? So what do we know from the previous tests? What the user sees is that the speed test is slow. What we saw is that the RSSI and the noise were consistent, okay? There was no fluctuation. However, the data rate was fluctuating, okay? Latency was seen on the wireless. So I think at some point I'm going to get a massive tattoo on my arm with 10, 128, 128, 126. If you guys don't know what it is, this is an IP that is used to host the local status page of an access point, which means if you ping that IP, you're only testing connection and latency over wireless. The moment you ping your gateway or 8888, it's anything beyond wireless and the access point. So do take note of that. It's a very cool IP to remember. And yes, we also see that the speed test is slow. Okay, so yes, users see speed test slow. We also see that, but as a last thing. So now, what can we actually say about it from the perspective of us being amazing wireless engineers? So RSSI and noise being consistent, it means connection is stable. Data rate fluctuating and latency on a wireless, medium must be busy. I have issues accessing the medium. I'm losing the contention process. This is where we want to focus. And the one side and speed test we can look into once we are able to get access to the medium. So let's ask more questions. Does the issue happen during specific days, during specific times? All the time. So the first tests were run around 2 p.m. So I decided, okay, I trust you, Mr. Customer, but I'm going to stick around after 6 p.m. when everyone is gone and repeat the same test. And surprise, surprise, it looked okay after hours. So then I asked, okay, is it location specific? Do you see it everywhere? Customer confirmed it's location specific, okay? So on the dashboard, if you have floor plans uploaded, and I hope all of you do, because it's an amazing troubleshooting tool, people don't realize, we can actually select specific markers to show us specific data on the map itself, okay? So here what we did is we looked at the number of current clients per radio in customer's network. So here we see that those two are serving around 40 access points, 40 clients per access point, okay? Then when I inspected a performance tab of those access points, then we see some latency, we see specific clients reporting that latency. We already know more about the problem, okay? And then customer says, yeah, but it is a Cisco enterprise access point, 40 clients per radio should be fine. Yes, it should be fine, but there was one more thing. When we looked at the actual channel plan, they used exactly the same channels. So suddenly you didn't have 40 clients per access points, you had 80 clients per single channel all competing for the medium. Apparently this was a result of some internal testing. They forgot to change it back to RRM. And after we went back from the static channel assignment, let the RRM do its magic, whether it was 10 in the morning, 12, 2 p.m., speed tests, ping, and everything was amazing, okay? How else could we identify this issue? The AP neighbors page, right? So if you go to wireless RF spectrum, you have access to this page, where if you click on a particular access point, you'll be able to see all the statistics about all the neighbors that the AP is seeing, okay? So this is something that could easily have been picked up if we just looked at that page. But again, we like to go through the pain and spend 2 days on site troubleshooting. Okay, another problem. Customer deployed 300 APs, and suddenly they face similar problem in the entire network, okay? So no longer specific to a specific location of the building, entire network is having issues, okay? So a couple of years ago, we introduced RF health into the Meraki dashboard that gives us a state of RF in the network. So here we're seeing that all of the radios are reporting issues, all of the APs are reporting issues, and we see that the health score for the RF is actually pretty bad, right, throughout the working hours. What was happening is customer, took those APs out of the box, plugged them in, and out of the box, those APs are unfortunately enabled to do dual 5 gigahertz mode. So instead of having 305 gigahertz radios in that environment, suddenly there were 605 gigahertz radios enabled. So the channel management was difficult. There was no oxygen left for the RF to work. So just the traffic from the management traffic from the APs itself was already failing, okay? With a single click of the button to disable dual 5 gig, we were able to increase the health state to be at consistent 90, 95 plus even throughout the working hours, okay? So after customer had some fun with this network, they decided to adopt 6 gigahertz, okay? And it's super cool that we're now seeing a lot of people adopting 6 gigahertz, but they enabled 6 gig, supposed to be super fast. We promised so much stuff with 6 gig. They have very similar problem that they did with 5 gig. We look at the RF spectrum page, RF health page, and what do we see? We see all of the APs nicely stacked on specific channels, okay? There's something special about those channels. So 6 gig was supposed to be the savior of the spectrum, okay? It gives us a lot more frequencies. Unless you're like me from Europe, then it's almost identical to 5 gigahertz. So the main difference is that there is no DFS, right? So there is no radar detection that's needed. But also, there was something new added, which is called PSC. PSC was added to provide efficiency for 6 gigahertz. So PSC stands for primary scanning channel, and these are the channels where the AP will advertise its presence, okay? At very early days of 6 gigahertz, it was believed that the clients will only ever connect on those channels, okay? So even though you can have, let's say in Europe, we have 28 6 gigahertz channels available, people were making a channel plan only with those 6 PSC channels configured because they were afraid the client will not discover the network. That's no longer the reality. We've been doing a lot of testings with smartphones, laptops from almost all the vendors around the world. As long as you have any SSID broadcasting on 2.4 and 5 on the same AP, the client will have no issues discovering this because there is a method called out of band where in the beacon being sent on 5 gigahertz or 2.4 gigahertz, the AP announces the presence of a 6 gigahertz radio, okay? I also did an experiment at Cisco Live Amsterdam this year, where I wanted to do 6 gigahertz only network that was hidden to provide more capacity. So because I wanted to do that with 6 gig only and no 5 gig, what I did is I have created a hidden fake 2.4 gigahertz SSID. I called it You Will Never Connect. I made the ciphers and security so difficult no one was able to connect. But because of the scanning behavior of the clients, they would scan 2.4 to look for Cisco Live SSID. They would see a hidden beacon, right, with no name. But because that reduced neighbor report, this RNR element will say, hey, on the same access point, there's 6 gigahertz, check this out. The client will immediately go to that frequency and connect without any problems. So there's always a way. So the goal is for us to use all the frequencies. So for this customer, what we ended up doing is, we made a very nice channel plan. Actually, that was a result of AI-RRM doing. So yes, AI-RRM can also fix your network. And we were also able to go wider, okay? So before customer was afraid because I made him afraid of the 20 megahertz. Not only we were able to use all the spectrum, we were also able to use wider channels, okay? So provide better performance for the clients. But now to anyone in this room thinking whether to adopt 6 gigahertz or not, am I ready or not? Well, the biggest dilemma is not whether I want to use PSC or non-PSC. The biggest dilemma of 6 gigahertz is whether to WPA3 or not to WPA3. And I've been speaking to a lot of people this week, and people are still afraid of WPA3. Don't be. We've been running WPA3 only at Cisco Live EMEA for the last 2 years, 20,000 clients onboarded without any problems, okay? WPA3 also brings its own challenges. So WPA3 introduced the concept of, well, it made the concept of PMF, protected management frames, mandatory, right? So what happens is every time you associate to an AP, there will be a process called SA query, okay? So if you're deploying WPA3 with PMF enforced, if you use fast transitioning, because you're adding key caching, the SA query doesn't happen anymore, okay? Because you're already pre-authenticated. So that's a very important thing for you to keep an eye on when you adopt 6 gigahertz. And a few more pro tips on the 6 gigahertz adoption. It should be your #1 priority to make sure that the 5 gigahertz radio and the 6 gigahertz radio look the same to the client, okay? You don't want 5 to be 6 decibels stronger, and vice versa, you don't want 6 to be 6 decibels stronger, okay? But one thing you do have to take into account is that 6 gigahertz is a higher frequency compared to 5. So most of the time what I do is when I have a transmit power range for, let's say, 5 gigahertz set between 8 and 11, what I would do for 6 is I will offset it by 6 or 6 decibels more, okay? So 6 gigahertz RF profile will begin from 11 to 14 or from 14 to 17, okay? This is very important for MLO, also Wi-Fi 7, because you want the two links to appeal the same to the client, because then the client will just never use the other link, right? We'll use the strongest. And there's also a couple of things that we can do to onboard more clients onto 6 gigahertz, which is the use of wider channels. So here's a graph that shows a 6 gigahertz adoption, open office space, open office space in the UK. So the blue line shows you the number of 5 gigahertz clients connected at the time. The pink line shows you the number of 6 gigahertz clients connected at the time. You can see that throughout the first weeks, most of the clients were still prioritizing 5 gig. This is because the transmit powers were not aligned, okay? And 5 gig was still stronger compared to 6. So this is where we did an offset of transmit powers between 5 and 6 gig radios, yeah? So suddenly you see an uptake in devices connecting to 6 gig, but the biggest uptake happened after we made 6 gigahertz slightly wider, okay? So 5 gigahertz in that environment remained using 20 megahertz, and 6 gigahertz we configured to use 40, and you can see that ever since, 6 gig was prioritized, 70% of the clients were connected to 6 gig. this network works very well. So this customer doesn't want to go away. And they come back and say, we noticed the same issue. 4 times they noticed the same issue. But this time they checked the channel plan, everything seems fine. So let us not forget to review the actual state of the RF itself. Okay? As I have mentioned, we have started to include RF health metrics in our dashboard. It is available in multiple pages, RF health, assurance. What this metric actually gives you is all of those individual scores. And my personal favorite thing about this metric is if 7 of them are 100 out of 100, but only 1 of them is 1 out of the 100, the RF score will be 1. Okay? We want to show you exactly which AP is failing. Okay? We don't want to sum those up, then average, and oh yeah, everything is good. No, we want you to be aware that this AP is failing and tell you exactly why it's failing. Okay? So here we see CCA busy. What is CCA? CCA is a fundamental method in wireless, 802.11, used to access the medium. Okay? This is the first step to transmit any single data over wireless. CCA stands for Clear Channel Assessments, and it's not as difficult as the industry made us think it is. There's 3 steps of detections. First of all, we detect any legitimate wireless signal. Okay? We care about legitimate wireless transmissions up until -82 of RSSI. Then we look at energy detect. Is there anything on the medium that we don't understand? Okay? So 2.4, a microwave, right? Why is that an energy? Because it doesn't use 802.11 protocol, but we can sense the energy on the air. Okay? And in the virtual carrier sense, we use the data from any traffic being sent over the air, because if I'm downloading something from YouTube or Netflix, then I am telling everyone, hey, I'm going to be occupying this channel for X amount of time, and access points and clients, upon seeing that duration, they will back off. Because if someone said, I'm going to be talking for the next 2 minutes, why would we even try to see if there's someone out there if someone told us, I'm going to be here for 2 minutes, right? We have multiple tools on the dashboard that will allow us to validate the state of the RF. My personal go-to is the spectrogram. I'm the RF guy, so I spend a lot of time in the spectrum. But we can also look at the utilization graphs. It will show us exactly what is the split and what is the state of the medium itself. Okay? Something super cool that I'm excited about, starting in MR33, we are bringing Clean Air Pro to the Meraki dashboard. Here are some of the mock-ups of how the future might look like. It will help us to identify non-802.11 interference sources. We've tested it in a couple of locations. It's really good. Okay, so back to the customer. Some random issues, right? Looks the same, but not really. Channels look good. So we noticed that there are random spikes being reported by the AP of non-802.11. Okay, and the same graph is already available under AP details page. So something's in the air. So we went on site with a spectrum analyzer, and close to the AP, we didn't hear a lot. There were occasional spikes, but close to the client, we saw a very nice narrowband interference. This was an area where they were testing a new lighting system. It was only one client that was directly underneath that lamp that was reporting issues. So again, sometimes AP may not hear everything. Sometimes, wireless can be weird, and it only takes something like this being heard by your client to have issues. Okay? But what if that interference is Wi-Fi? Here's a scan coming from a customer's network that has a train station in the middle of their building. Okay? So the train station decided to introduce their own wireless network. They used 80 megahertz channels, and all of the channels they used were Uni 1. So what can we do about it, right, if we want to use Uni 1? Well, we can put some noise-canceling headphones on the AP itself. That noise-canceling headphone is called RxSOP. RxSOP allows us to make the AP immune to what is happening in the environment itself, okay? We can tell the AP to start ignoring some of the traffic beyond specific values. The default one is -95, so it's very high. I always like to start with -82, -79. But be careful, because if you don't have enough access points in your network, that may cause issues, okay? So be very careful in areas like warehouses or somewhere where you cared about just the coverage and not the capacity itself, okay? To show you the impact of RxSOP, here's a line of where -79 is. Anything below -79, we can simply kill. It doesn't get processed by the AP. It gives more availability to the medium for the AP itself. Here is an example where in customers' network, we saw a lot of misbehaving Raspberry Pis. So the maximum value of the duration field is 32,000. As you can see here, those devices were setting the duration field to the maximum value all the time, which was causing the channel utilization reported to be very high. The moment we set the RxSOP to -79, utilization went from 80% to 10% immediately. So that was pretty impressive. And client may get weird, because utilization is actually being reported inside the beacons. Inside the beacons, there's a field called QBSS element. It includes a channel utilization, and whenever it's very high, clients may decide not to connect to that AP. They might decide to roam. So definitely be aware of some of the impacts of utilization. Now let's talk about roaming. Let's agree to disagree, but let's agree that roaming is a client device decision. There's nothing we can do about it. We can enable 11K, 11V, all the fun stuff. It's still up to the client to decide when to roam. There's some good vendors out there that provide amazing documentations. I'd like to think that Cisco is also an amazing vendor and we provide amazing documentations. But let's talk about roaming. Roaming can be very intrusive, okay? And let's talk about what is actually roaming and what can trigger a roam. So a client that is between the cell edges of a connection, right? So right between two access points, this will trigger a roam. The roam can be triggered by an access point itself. If there's a RRM change, if there's a DFS, if it stops sending beacons, that may trigger the algorithms to roam, right? Then it can be all sorts of infrastructure weirdness, RF events, or it can be triggered by client events. I'm moving quite a bit on this stage. I'll probably roamed 50 times. What happens behind the scenes is client has to select an AP candidate it's going to connect to. Then it has to reassociate. Then it has to authenticate, which is optional if you use fast transitioning, and then create the encryption keys. There are good roams that take very little amount of time, that are happening within the same band, right? So that saves time on the scan time. When client goes from 2.4 to 6, that's also considered a good roam because the experience is being improved. And most importantly, when we get better RSSI, because we end up getting better and higher rates. A bad roam is when the transition takes seconds, no key caching is being used, when we ping pong between the APs, when we go from 6 to 2.4, from 5 to 2.4, when we end up with low RSSI, or when there is no roaming at all, okay? Because then we might have also a failed roam, or we can attempt to scan and connect with old information. Roaming used to be very difficult to troubleshoot, but in Meraki we have two amazing pages that help us identify what is happening, what is the history of this device connection. So, customer comes back and says, CEO can connect, but when moving there is a drop. And we go back to our lovely page of timeline, and we see that every roam takes 25 seconds to authenticate. So that to us already says, okay, they definitely don't use any key caching because 25 seconds is a bit extreme. So what can we do about it? 802.11r, okay? Fast transition enables key caching on the APs. APs exchange all the information, and it allows us to go from roaming taking a lot of time to taking a fraction of milliseconds. Don't listen to me, listen to AI, okay? AI will also tell you that 11R is amazing and you should use it. Customer doesn't want to go away. They experience random drops, okay? So let's see. Roaming, as we said, can be triggered by channel changes. Okay? It can be because of RRM. It can be because of DFS. Okay? What can we do about it? Well, we can enable busy hour. A busy hour will tell RRM, hey, only make the changes when needed. Okay? Don't make the changes during production hours. DFS, not much we can do about DFS. If the radar hits, there's nothing we can do. We have to change the frequencies. This is the law. What happens is we detect the radar. AP has to select a new channel, announce the new channel to the clients, move to it, and it will not move back to its original channel for up to 12 hours as long as it's serving clients. One of the things to be aware of, when the AP is actively serving clients, it will also prioritize non-DFS channels. So if you're near the airport in a DFS busy network, over time, the network can look very bad from the channel plan perspective. In order to save us, we can use AI channel plan that will keep track of all the historical bad events in the network. It will come up with a list that it will blacklist specific channels that have seen the DFS event multiple times. Okay? Be careful, because I saw a warehouse that was right outside of Heathrow Airport. They had this feature switched on. They had only 2 channels available left. So yes, AI is not always helping us. And guess what? Customer comes back. We fixed the RF. We're still not quite happy with the performance. And remember what I said at the beginning. Maybe it's not the wireless issue, right? Maybe it's something else. So then it's very important to look at the list of all the access points, right? So when you go to wireless access point overview, and you have a list of all the APs, there is a lot of interesting information that will help and guide you and identify what is happening, okay? So we see here that all APs are online, right? There's nothing that dropped recently. We see that they are connected, but some of them are using 100 megabit speeds, okay? So that may cause some performance issues because they will not get as much throughput as the clients connected to an AP that is sitting on mGig connectivity. An AP became a repeater. Some AP dropped offline 7 days ago. We didn't even know about it. And also multiple software versions being used, okay? Very important thing for everyone to remember. With the introduction of new firmwares, older legacy APs, specifically Wi-Fi 5, they won't upgrade beyond specific firmware versions. So if you have mix and match, salt and pepper approach, be careful, because that also may have impact on how the APs communicate to one another. So 2 weeks later, we have fixed everything. There's nothing else for us to do. Clients were able to join. We optimized 6 gigahertz. Everything is fine. We killed all the rogue devices. And customer says, I am losing access points. Completely random. Every single day I'm losing a few. And we're like, I don't know what else to do. You have to inspect it. You're on your own. Customer goes, and they see this. Then they open one of them, and this happens. So make sure to protect your APs. Make sure to use correct enclosures. But yeah, after that, our customer was happy. We fixed all the issues, and now we can go and enjoy the party. Thank you guys so much. Do remember to submit the feedback. Thanks.